Congratulations, you have made it to the very last topic in this chapter, which is complex numbers. Complex numbers deals with numbers that you've never seen before. They're called imaginary numbers, and we're going to get to that in a minute. But first of all, here's some questions that come up during this part of this chapter. Why do they exist? Well, thank you, Mr. Harden, for coming up with an answer for that. Where do they exist? Also, Mr. Harden. And here's some jobs of the future technology being developed right now. Pretty cool stuff going on here. So let's jump into this. Here's the key idea. The square root of -1 is equal to this imaginary unit. We call it I. And so you can read this for yourself, but literally you're going to treat it just like x, for example. There's just a few things you have to keep in mind. So if I has an exponent, then it can be other than 1, then it can be reduced. So there's a cycle of 4 different monomials that you're going to get depending on what power of I we're talking about. So here's the cycle. I to the first is just equal to I to the first. I squared, but I mean, remember that that represents the square root of -1. So I squared is really I times I, which is the square root of -1 times itself, which is just -1. So the same rules that happen with real numbers, you cannot apply them to complex numbers. So before, when we would multiply radicands, can't do that with complex numbers. So then I cubed would be I squared times I. And we just figured out that I squared is -1. So that's really -1 times I, which is -I. I to the fourth is I squared times I squared, which is really -1 times -1, which is 1. And once we try to do more from there, this cycle just repeats itself. So let's say I tried to do I to the 5th power. So that's really I to the 4th times I to the 1st, which is 1 times I, which is I. And we just go right back into the cycle. So the cycle is I, -1, -I, and +1. You are only going to get those 4 when we're dealing with I. Okay, so you should never, ever, ever have an answer with I in it that has an exponent greater than 1. Might want to jot that down somewhere. So we're going to simplify some radicals, and we're sort of going to do this the same way, but we're going to address this negative first. Just like when you have a negative exponent and you address the negative in the exponent first, let's address the negative under the radical first. So I'm going to, right away, I'm going to separate it out. And lucky for us, 16 is a perfect square, so I can just take the square root of that. Square root of -1 is I. And so the square root of 16 is 4. Don't leave it as I4, put that coefficient in front. Now, if I'm simplifying something like in number 2, I want to just try to relate it to the powers of I that I already know. So I to the 7th can be broken down to I to the 4th times I cubed. And we already figured out what I to the 4th is. It's 1. We already figured out what I cubed is, which is -I. And so we would get -I. So you never want to leave it with an exponent greater than 1. I to the 12th, we can kind of do the same way. I would write this as I to the 4th times I to the 4th times I to the 4th. And we already know what I to the 4th is. It's 1. So this is 1 times 1 times 1, which is 1. I may or may not show you the shortcut here in class. I don't know. I gotta think about that. Try this one. Good luck. Here's example 5, getting the multiplication. So this is 5i times I, so it kind of works the same. This just treat I as a variable. So I would get 5i to the second power. But again, we don't want to leave it with an exponent greater than 1. So I squared is -1. Refer back if you forgot that. It's going to become kind of second nature. We're going to be practicing with this, and you're going to be like, oh, I squared, it's -1. So we get -5 here. Number 6, again, let me just remind you, say it one more time. You cannot follow the same rules as we do with real numbers because these are not real numbers. We're going to do imaginary numbers now. So that doesn't mean they're not here. It just means that we just have to do it a little bit differently. And so I'm going to simplify each of these first and then multiply it. So the very first thing I'm going to do is get that negative out of there. Okay, so this would be I times 2. This one we have to do a little bit more. So this is all multiplication. Keep that in mind. So this is, I'm going to keep this in parentheses, just keep them separate. And so this is going to be I. When you simplify the square root of 18, you're going to get 3 radical 2. Everybody should know how to do that by now. If you don't, come and see me. So what we get right here is 2i times 3i radical 2. That's kind of the order that you would put these 3 in. And then I can go from here because I can continue multiplying. Because it's multiplying, I don't need like terms to combine these. So this is going to be 6i squared radical 2. And I squared is what? Oh, -1. It's very healthy to talk to myself. And so this becomes -6 radical 2. All right, here's number 7. Now, because we're adding, you do need like terms to combine. So literally, you're going to combine that and that, combine that and that. Now you're not multiplying these, you are adding them. There's this huge, well, it's not huge, but it's a huge part of this problem because there's an addition sign there. If there was no addition sign there, then we'd be multiplying and then rules change. Stay tuned for that. So try that one. That one's in red. Number 8, I'm subtracting everything in the second set of parentheses. So I'm going to change the sign and change all the signs inside the parentheses. So I'm going to combine like terms. I have 6 plus -8. That gives me -2. I have -2i and -4i. Combining that will give me -6i. Remember, don't do anything to the exponent, just like if this was an x. Okay, so that's the answer. And that's the standard form for complex numbers. The standard form is a plus bi, where a and b are integers. Or I shouldn't even say that. Or it could be real numbers. So now we get into multiplication. And again, this is same rules. So I'm going to use double distributive. I'm going to multiply 6 times 8 and then 6 times 4i. So 6 times 8 is 48 plus 24, oh boy, 48 plus 24i. Then I'm going to take the -2i and distribute that. Don't forget to also distribute that negative. So I have -16i minus 8i squared. Oh, what's I squared? So I'm going to combine like terms. And I can actually go further with this because, so I have 48 plus 8i minus 8 times -1 because I squared is -1. So 48 plus 8, right? Negative 8 times negative 1. So I can go ahead and combine those two, and I'm going to write this in a plus bi form, which is how you should write complex numbers. So 48 plus 8 is 56, and then bring down the 8i. Okay, so all the same procedures for multiplying two binomials, but you have to just address that I squared. So when we go to divide, I'm going to show you this one in class. Stay tuned for that. All right, so now we get into solving. And when we solve, we can actually do this by just subtracting 30 from both sides. We're going to get into solving quadratics later on this year. Stay tuned. But for now, I'm just going to subtract 30 from both sides. And so I have 3x squared is equal to negative 27. Divide both sides by 3. And so x squared is equal to negative 9. So I want to solve because I have a squared term. I'm going to take the square root of both sides. Now here's a key part to this procedure, and I'll be repeating this throughout the year. If you're the one that introduces a radical to solve, you also have to introduce a plus or minus in front because you have two different roots here, principal and negative root. All right, so I'll be repeating that several times throughout the year. So this is x equals, I'm going to leave that positive and negative there. I'm going to take out the negative. And so this becomes positive or negative 3i. Do you see how I got that? So the square root of 9 is the 3. Square root of negative 1 is the I. Plus or minus gets brought down. So you have two answers here. X equals 3i and x equals negative 3i. Okay, you try number 12. I was going to have you do number 13, but I kind of want to show you this one. So notice that I have a complex number right here, 3 plus 4i, and all this nonsense over here. This problem is actually kind of easy. You just have to kind of break it down. So what I'm going to do is set the real part of the complex number equal to each other. So I'm going to have 3 is equal to 3m. So the directions for this would be to find m and n. And so I'm going to divide both sides by 3, m equals 1. Then I'm going to take the imaginary part of this complex number and set those equal to each other. So I have 4i is equal to negative 8ni, and I want to solve for n. And so what I'm going to do is divide both sides by negative 8i. Do you see why? I want to get rid of everything I'm multiplying n by and reduce. So the I divides into itself, and I'm going to reduce 4 over negative 8. Don't switch those. Don't put the negative 8 in the numerator in your mind. So this reduced becomes negative 1/2. And that's what n is. Okay, so that's our answer, m and n. Our last example here, right in the form of a plus bi, you just want to pay attention to what part of the complex number you're given. Are you given the real number part, or are you given the imaginary number part? So in the first example, I get the real number. So literally all you do is do 7 plus 0i. You're just tacking on that extra part to write it as a complex number. Here we're given the imaginary number part, so it would be 0 plus 2i. Boom. You can add that at the end if you want. All right, that's it. I know it was long, but hey, it's the only video for a while, so it's all good.